Right, do I have music? I don't know. I'm playing broadcastable music. But this looks too loud. What the fuck, man? It's also too loud here. Yeah, if I put it like this, I should turn it down a bit. Let me see how that works. Test. Test. Okay. Hello, testing. I think this volume should still work. Maybe all the way up here, but not totally in the red. Hello, 1, 2, 3, 4. I think that should work. Certainly if I sit like this. And then you have to go, oops, back here. Testing 1, 2, testing 1, 2, testing 1, 2, testing, test, test, test. That's distorted. But I'm not usually shouting, I promise. I'll take it to 1 minus 3 decibel on the OBS input. Yeah, I don't know, man. I have minus 45 dB something. Is it noise or is it music? Tune tank. That's what I hear. I think this is the music. Yeah, now you guys have music. So that's better than coughing, which I do usually all the time. Hello, test okay. I can't read your name, but that's okay, really. Live chat. Okay, let's do it. I fixed it, everything. So now we have these points. These are 5,000 points. And the width is from minus to plus 3 times the standard deviation of the logistic distribution that is being used to blur red and green over this line here. So it's kind of continuing till the third standard deviation. So that is 5, a distance of 5. So let's say 2 higher. That is like here. So yeah, you can see there are still 2 dots at a distance of 3 times standard deviation here. And on the other side, it completely goes off because I'm shifting the line away from the origin. Also randomly, but up till a distance of 2 standard deviations. So it could be 2 shifted plus 3 that you still see points, so it's like way off the graph already. I think I want to test it anyway. So if we run this again, return. So it just generates it at different scales, but the image is just, it's always the same. It's just rotating and shifting left and right or up and down. And the scale is also different, but you don't even see that because it is now working. Let's try to get one that is in the middle for the, oh, whoa, that one is on the edge. That's weird. That's weird. It looks like it shifted almost as much as the should not be shifting that much. I mean, there's 3 standard deviations. I think it should shift at most 2. So that then it still doesn't work. I'm going to turn my music a little bit down. If anyone else here wants the music to be turned down, tell me. Wait, I need to have my volume control. Nothing, it's not here. Hey, you can hear myself again. Right, now generate points just generates points. I mean, the line is the bit weird word. It's also including the X and Y range and everything. It's more like the whole picture. So I'm getting the X and Y range from the line, and then we just generate uniformly distributed points for the X and Y coordinate. Fill that in. That's everything. So it's, yeah. Doesn't get any easier. And then after we have the points, and the only difference is then the X range varies. So maybe I should look at the line constructor first. Also has random stuff in it. The line constructor generates the angle theta between minus pi over 2 and 3 pi over 2, which is, by the way, a whole revolution. So it's every angle is possible. Then the scale factor generated as inverse from a uniform exponent of 2. So we get 2 to the power from 2 to the power minus 2 to 2 to the power 2. And then we have another uniform distribution here, which should be between minus 2 and plus 2, the standard deviation. Really looked like it was shifted more than that. Hey, Daryl. AKA Hesper. Trying to understand if this is correct. So we do x times this plus y times that equals minus that. Just cheat and make a. So we have W0 times x plus W1 times y equals a minus W2. From which follows that y equals minus W0 divided by W1 times x minus W2 divided by W1 Yeah, then of course the vertical distance can be huge, but what? This doesn't really help. Doesn't really help, does it? Or does it? No, it doesn't. Nope, we have to try harder. Let's define n as w0, comma w1. But I want n, the normal, I want it to be a unit vector, so the length must be 1. So I wish I did not multiply with S inverse. aka we can divide it again by S inverse or multiply by S, that's the same thing. By multiplying by S we get back the sinus and the cosinus. So then sinus squared plus cosinus squared, and then the square root is 1, that's the length of n. Now what is S? S is what is being returned here, which is the square root of w0 squared plus w1 squared. So this squared plus that squared, and then of course the sinus and cosinus do their thing again, and you end up with S inverse squared. And then the square root of that is 1 over S, and then 1 over that is S itself. So yeah, scale factor is S, and that's what we are going to multiply with. So if I set n to be this, then we have a unit vector that is a normal to our line. And now I want to know what distance is, so we're going to say if I add, no, I have a line kn. So if you vary k, then you run over a line that which go through the origin. For k0, it's the origin. And I want to find the k at which point this crosses my actual line, which fulfills the equation w in product with kn plus w2. Let's write that out actually. So kn is ks times, well, why not like this? K times this, comma k times that. Yep. And then the in product with w, or wkn, is k times s times w, so then this must be squared, and this one is multiplied with w1 . And the line equation is this. So if this is true, then we found the correct k, or the intersection. So So we can write that as... Oh, wait a minute. This is the in product. I'm an idiot. I have to add it. Which we can then write as W0 squared plus W1 squared times K times S. Well, W0 squared plus W1 squared is thus this squared plus that squared, which is this squared. So this is 1 over S squared. So this is K divided by S. Hopefully I'm not making a mistake here. I think it's correct. So then this can be written as K divided by S plus W2 equals 0, from which follows that K is minus W2 times S. And since I used a unit vector, then K is the signed length, because it's the number of normal vectors that we add to the origin in order to get onto the line. Yes, that is definitely the distance. Could have used D instead of K, because N is normalized. Well, that, my friends, is equal to, well, W2 is equal to minus the distance times S inverse. So if you multiply that with S, then we get W2. So the distance is W2. No, it's not. It's the distance. I'm an idiot. Distance. Yeah, this minus drops away against that minus, and the S inverse cancels against this S. So we're left with distance. Yeah, well, I don't know. And the distance is between minus 2 and that. Well, let's override that for a moment. So I set this to 0, then obviously we will only get lines that go through the origin. Origin is in the middle here. Can we draw 2 lines so I see exactly where the origin is? I want to draw a grid actually. Time to ask ChatGPT. How do I get Knuplot to draw a grid with spacing 1? Right, well, I think it suffices to add that to the draw line function. Or, I don't know, not a number. No. Oh well, actually yes, but it's incredibly hard to see. Oh my, that's very, 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 very hard to see. I don't see the ls back here. Apply the custom line style to the grid. Grid back ls1. Maybe it's this one. Let's try it out. Let's just try it out, and then we go there where the set grid. Yeah. Yeah, much better. So now you can clearly see that it goes through the origin, totally 100%. And now I set a distance of 1. Oh, I have a good idea. Yeah, let's do that. What command would also draw a circle with radius multiplies 3, so I know where the radius goes, and the same line style. Circle around the origin. It's not the same line style. There's a circle here, but it's wide. Why is it wide? unrecognized. Oh. It's, weird. Hello VS. No, I don't think my videos are very suitable to learn from. It's I don't know. It's probably better to look at the source code itself if you would want to learn from me, instead of waiting hours and hours to see it grow slowly. No, I don't think we have a circle at all now. It's still the same problem. Huh. Coding means for me C++. So, I do it in C++ or I don't do it at all. Why is this not working? Because ChatGPT is full of shit. I just have to look it up, I think. Maybe I can find an example online. Can you plot set object circle? Can you plot set, oh what the fuck, set object circle? No circle inside. What the F, man? Undefined variable x. Object x. X is the name. I'll call it 1, I guess. Yep, now we have a circle. Can't say it looks like it has a diameter 1 though. Sorry, a radius. Totally not. Radius 1, then it should have come there. It's less than that. What the hell? Why is it so small? Oh, this one is even smaller. This is a... Nah, what the hell? I think that this is the radius here. So if I make that to 1. Nope. Possible. I just need a GNU plot documentation, because this way we are not getting anywhere. Fuck. Questions, set object index circle at or center position size radius. Index is the object number, position specified center, and radius is circle radius. Well, I specified a size of 1. And as you can see, I mean, compared to the well, the y-axis here, or the x-axis, it's not 1 at all, not even close. This is 1. It's at least 4 times too small. Ah. Okay, thank you. So the problem was that I had X's there. And it does work without the X's. So now if you set distance to 1, then the line should be exactly on the circle. And it is. Because I like to see when something is, from which namespace something is on. It's also very, very nice to be able to grab that. I seldom use a using namespace or any namespace. I think it just makes the code less clear. The purpose of a namespace is not that you have to type less. It's to be able to resolve name collisions. So we run into a name collision, then we say, well, I want to use that namespace. Or actually, if I just type the full namespace, you don't get a name collision anyway. Based on decades of experience, it's definitely better to use std:::. than to do a using namespace standard. Maybe if you had a special editor that is aware of C++, so it kind of compiles your code while you're in the editor, so it knows which variables or functions resolve to which namespace. Yeah, but the compiler knows that if you just use POW and you have a using namespace somewhere, then it knows that it comes from standard. And then if the editor would also know that, and you could assign a different color to standard, then I don't have a good argument anymore to type it, because then you would have a special color for std and you would just immediately see it. But I would require a very special editor. I don't think that exists yet. Of course, I can add coloring. I could say POW must be colored purple, and then it's the standard. But yeah, it's not. If I define POW myself, then POW is that, and it doesn't know about the std POW anymore. And the color would still be purple because it just looks at the string POW. What was I doing? The distance, yeah, I want to find out the distance. We are inside line, so we go to the definition of line. Here, the only thing we have is W. I think that the distance was like yeah, minus this times S. That's the distance. So like so. Hopefully I have an S. Don't have an S yet. Jesus. Yeah, I'll just put it in here. Great, now we have arbitrary distances, and yeah, you can still see that the line is at that distance. So what is the standard deviation? This is the distance, but not really. So it would be this times S, right? Maybe you should print the distance here as well. I can just print the distance, I guess. By the way, 2.44733 times 0.612. That is 1.5. What is the distance? Because I set it to that. And that is displayed correctly. totally works. Good. Arbitrary distance. Maybe I should also draw lines at parallel at this line and then add standard deviation distance. One standard deviation on both sides. I have to cough again. I don't think I'll ever get better. This is the nastiest, slowly killing virus ever, I think. My brother thinks that it is RS or something like that. Seems a lot of kids and babies have are in hospital because of it at the moment. I must just be young. That must be it. Line, triangle. RSV. Okay, could be. Yeah, I have a month now. Month. That's ridiculous. I've never been like that before. I've been feeling ill for like 7 weeks before, and I was already like, what the hell? I think now I'm at 15 weeks. Double it. It's ridiculous. If I just repeat this, just call the set arrow from twice. Is that not working? Should wrap everything here. Yeah, well, I'm at a double of the maximum then. It's really strange. Well, it's getting better. So. It's particularly getting better since I started to go for a walk every day. And of course, today I didn't. That's really bad. Tomorrow I'll go again. I think it's now Saturday, right? Yep. Tomorrow going to my parents again. Coughing and all. Poor parents. Well, I haven't infected them yet in the last years, so apparently possible. So we repeat this block 3 times, and we have 3 lines, I think. See if that compiles at all. It does compile. And then I need a plus or minus distance, so we do for double, let's say the standard deviation distance is I don't like comparing floats. Let's just use an integer, and then we call that standard deviation. Oh, horrible. Runs from -1 until and including 1, incremented by 1, and then here we can add the distance plus something which is actually then SD times. So in the middle we have we add nothing, and then we add and subtract the same thing. And the amount we have to add there is, well, I want the standard deviation, so let's begin with that. I definitely need my S now all the way up the top. S. Oh, I threw it out. Your multi, no, it's just 2. Wait, I need to S somewhere. Times S. X range is -3 times S. Why is the previous one not times S? Oh, because this distance is multiplied by S there, except that we divide it. This is bullshit. Yes, you can ask me another question. Chemical chems. Yeah, that's why we do it. So people don't feel alone while they are coding, including me. That's a good question. I don't know many other languages, so it's hard for me to compare. I can just say that C++ is not for the faint of heart. It's very difficult. And most people, even professional C++ coders, don't know how to really write good code with it. And it has a high, what is it? Barrier, as it were, for starting any application. So you need a lot of code to get even a little bit on the screen, unless of course you are happy with the terminal type thingies, like you know, playing around. That it's okay. It's what what I do. A terminal application. But say you want to write a game, or you want to do anything with graphics, a graphical user interface or something like that, then yeah, or you want to write stable, maintainable, robust code, and have an application of 500,000 lines of code, then the basis that you need is already that size, basically. But you could use my libraries, because I think that, well, what I've been doing most of my life is writing writing that base. So it's yeah, I don't know. I cannot imagine that any other language requires so much code before you can even begin. But on the plus side, you can do anything with it. You just if you feel brilliant and you have a perfect memory and everything comes easy to you, then C++ is definitely the language for you. Because then it's powerful and fast and stuff. And I have to cough again. Trying not to. Now I would say that I treated this as the distance, correct? But it isn't. It's only the distance when s is 1, because I think I have to multiply this with s, and if I don't, then I'll just have to multiply this with s, which basically means that I should not multiply it with the inverse, which then again is confusing like hell, of course. Let me try what happens. This, you would say this can't work because it worked without it, without removing it, but on the other hand, we crash now. Yeah. Try that again. Oh no, we have big circles, and the line is definitely not on it. Oh no, we don't have a circle at all, and we have lines up here. That those two lines are then the. Oh my God, what happened? Why is this so hard to get right? Impossible. Mission Impossible. The music. I need a jingle for Mission Impossible and then play that non-stop. Yeah, Chemical Kim's summed it all up. It's interesting, which is also the only reason why you should learn anything, in my opinion. I know they force you to learn all kinds of stuff that you don't want to learn while you are a kid. Maybe there's some merit in it, I don't know. But in the end, life is about learning what interests you. You learn 100 times faster then, so it is no matter what you learn, it's always better. I'll add this back because I didn't like the result. Well, we have 3 lines and one touches the circle. No, I can never get this right. If I can't get this right. I have an idea. Generate colors. No, it's the line constructor. So the idea here was generate lines at a random blah 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 blah. I'm just going to sit on the edge. Well, maybe not really on the edge, but yes, on the edge. Well, I don't know. I want the edge would be this. But I want to shift it now just once. One standard deviation. Now let's do plus. Distance vintage. So the distance here is generated as 1.8, and I should have printed S as well. I should just set S to something, I think, because all that random stuff makes it only harder. This one. So I set S inverse to 0.5. See, the circle touches the line, and we see then from the circle that it is the actual distance. This is the actual distance per definition. This is how much it is shifted. And the value is 1.8. So the line is shifted 1.8, apparently. So it's a real distance, but that's not what it should have been, because with a scale factor of 2, the whole thing is blown up. You see it runs from -10 to +10. So we zoomed out, as it were. And it shouldn't make any difference, meaning that the real distance should have been twice as big. We should multiply the actual distance with 2, so that this becomes minus 1.8 instead of half that value. Is that true? Should be true. Everything screams that this should be multiplied by s to make it a real distance anyway. I know why I didn't, but that's what the scale factor is for. So now it's the real distance. And when it is the real distance, which means I also have to multiply this one by s, by the way, then we just have to scale it again with the inverse here before applying it to, or maybe not. Wait a minute. Oh wait, yes, yeah. Because this calculation used the fact that it was divided by s, and this is the real distance, which is that distance. So I think this is correct. Don't have an s here. No, might as well work with s and then divide here by s. What the hell? It looks like ASCII art, the line here. Right, so now we see that the distance is 3 point something, 3.6 or something. Yeah, and that is what is printed as being the distance. And also equal to the standard deviation apparently. What? Oh yes, because I set the distance equal to exactly one standard deviation. Aha! Okay, so it now shifted one standard deviation because I said so. And then this line is 2 standard deviations the other way. It should have been 1. Why did that go wrong? The 2 is confusing. Let's use 1.5. So the standard deviation is 2.7. And the distance is 2.7. The scale factor is 1.5, meaning that... I don't know. Let's see if this is 2.7. Yes, it's 2.7. But this is more than the standard. It's just S times the standard deviation. It's 1.5. So I have to divide whatever this shift is by S, by the scale factor. It's not colors. What is it then? Drawing lines. Plot. No. Here it is. This one. So the shift is a bit too big. Right, because this is not really the distance. So this is now -1 or 0.01, and then SD is a real, sorry, this is -1, 0.01. This is the real standard deviation. But W is scaled. And apparently I just have to divide it again by S. So then we do that, and now it should be at a distance of 1 times, yeah. So now one line touches the circle, one goes to the origin always, and the other one is on the other side. This distance is 1 times the standard deviation, which is 2.7, right? So yeah, that is 2.7. I don't think I had to fix me then. The distance is now 1.8 again. No, it's not. Yeah, it's 1.8. Huh? What? Oh, this. Yeah, it's 1 standard deviation. I'm not printing the distance, but it's still shifted 1 standard deviation. I'm confused. Why? Because I didn't comment it out. Although I commented out the wrong thing. Let's put it that way. Yeah, no, that makes sense, because now the distance is smaller than the standard deviation, 3 times smaller. So this is on 1/3 of this total distance. So this is twice as long as that, I guess, ish. And that's another interesting one. I guess what is correct is that the scaling is such that visually the distance between these lines should be the same every time. Visually, because that's the standard deviation, and I blow things up relative with everything with standard deviation, basically. So yeah, they look the same. They totally are the same, right? Those distances. Yeah, very good. If this is one time the standard deviation, then now the shift can be up till maximum of 2. That distance. So the origin is here. So this is a little bit less than 2 times. And from here till there is 3 times, which is indeed the border of where red still occurs. I think I finally got it. The correctly generated training data. Okay. No, I have to think again. This is my training data. Points and targets. what to do with it. I'm thinking Z here is the output of the activation function, and it's a scalar in my case. We got that by multiplying W with the input. And let's use it for inputs. We have two inputs. Well, yeah, 2 and a 1. And I'll multiply that with put some paper. So, x0, x1 is 1. I multiply that with something, and then I want that to be, so this must be, that's just a row vector, W0, W1, W2. And that then is Z0, Z1, Z2, dot dot dot. Sorry, that's 0, 0, 0, 1, 0, 2, dot dot dot. Okay. Probably will help a bit if we just print it. Starting with print points. And now I have gotten at the point where I'm just going to use my stuff. All this standard out and then not being able to print vectors getting becoming tiresome. Shall I still postpone it? Okay, I'll postpone it. Cool point. So I have a vector of points where each point is x, y coordinate and a 1. And what I want is a tensor. Maybe we should convert it then. And this thing is not returning a tensor because let's just make a tensor. Okay, so we have a tensor. Now I call it x because it's just the whole x is my inputs, and this is the whole batch. Yeah, so batch size big thing. And I need to fix C-tags because I'm also getting very tired of not being able to jump around. My alias S does that, and that, and that. Definitely missing here. Yeah, source. Do I have anything here to begin with? I don't think so. Okay, so I did all these things. Building yeah. What the hell? Let's remove this one. As in, copy the line, comment one out, and print everything except the last find. Oops. Nothing. Suspicious. Oh, right. Wait a minute. Not S, LS. So I need to include this one. Maybe ops as well. Let's merge. Yeah, could do a find, I guess. Find for .cxx. But this one also has headers. Find .cxx or .h. Find repo base type f print. Definitely need a name there. Name star.h or name star.cxx with parentheses around it. And that should already include then everything. Maybe I shouldn't. Let's just remove this one and then search in repo base / source. Yeah. Not doing that elsewhere either. Nope. Unquoted pattern after predicate name. Oh, it's inside a single quote of the alias. Well, let's just use double quotes then. Does that work? I think so. Yes, now we have these as well. Good. Finally. Should have done that a month ago. Well, a few weeks ago. Shape. Just pass the shape, and I can even jump to shape now. Shape is index, which is an array of just an array. T is actually the rank, I think. So we call it rank instead of T. So we pass a single shape, and the shape exists of this. Now I've got it already. This size of, I think this. So yeah, this complete thing, size, including the size, definitely the size. So this is an 3 by batch size. Tensor, I think that compiles. Or not. No while constructor. Oh, I have to pass stuff, template stuff. It's a template. You have to tell it the number of dimensions, the rank, as it were. So the rank was 2, right? Rank 2, which means that we have 2 elements in the shape here. Non-constant expression cannot be narrowed from type size type to int. I can. Okay, then we get Well, that doesn't make any sense to run it yet. And then I have to fill it. So now we have X, and then the first one is a row, which is the X, Y, or Z. To X, comma, and then the sample. I would like to use S for some reason, but overloaded S. Let's call it J. Then is point X, and then this is 1, J is 0.1. These are not the same things, are they? If this vector is a tensor, it probably is, I think. I'm not sure. Actually it is. This is intersections. No, I'm not sure. Could be tensor 1. I don't know. Yeah. Just debug code this tensor stuff. Debug tensor. Now I feel like I filled my vector with 1 for nothing. Point 2 is already 1. So that's why I should be able to just assign the bloody thing. But yeah, I don't know. This should work. Let's see if it compiles. It does. So let's print X instead. Oh, that's a big thing, X. At least you can see it grow, I think. Increment J as well. See it grow. That was instant. Yeah, so it fills in the first point and the rest is 0. And then it fills in the second point and the first point is still there. Keeps being there. Second point 2. Third point is filled in until everything is filled in. So here we have the one that is not filled in, and now it is also filled in. So now we have a tensor that exists of all the training data points, x, y coordinates, plus a 1. And that's x, no reason to print it anymore. What is next? Next, we define a tensor called Z. And this tensor is one-dimensional, although it's the result of the contraction. It's probably also two-dimensional then. Oh no, wait, it's contraction subtracts 1. So this is Z, and that is equal to contract. Then we multiply W with X, and we run over the columns of W and the rows of X, and it should give us Z, but we don't have W yet. Let's make W first then. So W is tensor with rank 2, which is a size of 1 by 3. Let's assign that thing then. 0, 0 equals. Oh, this is exactly the same thing as we have in line. Maybe I can even copy it from there. I don't know what this line is returning here. Yeah, it is a tensor already. So I should just get tensor W underscore. Yeah. An accessor for it. No variable conversion from tensor 2 plus 2 minus 2, aka 2, to tensor 1. Oh, you still have a tensor 2 then. No, okay. And it didn't crash, so that's a good thing. It didn't print anything. Let's print Z. Z is this is Z. So Z exists of a single row. Let's open here, close there. And is that true? Sorry. Yeah, it should be a single row. And then we have stuff in it that is actually just a scalar, but then with square brackets around it. I think that's because the inner thing is a column vector. So we have a column here, but the column has a size 1, so that's just a scalar. And then the second square bracket means that the rest becomes a row. So because of the inner brackets, we see that this is a row vector. Without the inner brackets, it would have been a column vector. And the contents of these values here is the result of multiplying W with X for each sample. So this is WX, 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 and X is every time the next training data sample. So it's the output of the neuron, right? So the weights. Weight times X plus the bias gives me these numbers. Next we have to fill that into activation function. So element wise we want to change Z to pass Z through the activation function. I want to know how to call it then. See something else coming up as well. I want to get rid of. No, I can't. Well, I could make a I could make transpose that gets rid of it, if you get what I mean. So turn the row vector into a column vector. But it's exactly as efficient, actually. Just I store the tensors in a flat standard vector anyway. So there's no difference whatsoever. Works the same as TensorFlow itself. I don't think I even got inspired by it. It's just a logical thing to do. Let's look at backpropagation. So we pass z in through the activation function. See, that's my problem here. It wasn't z. Should have called it v, and then z is the output of the activation function. Let's call this v. And now we want to make a z, which is then activation function. And well, maybe I can find it. I made something called function. Here's my function. I can create a function from flow type in, flow type out, and then apply it element wise by calling this, I suppose. Passing a tensor, getting a tensor out, yeah. Yeah, I should have made a function from, I think I already made a function actually. I should have made a function of sigmoid. Yeah, that's the way to do it. And we already have it. We already have it in debug layer. Oh, that's inside layer. Well, nah, okay. Let's make my own. Not sure about sigmoid though. I don't know where that came from. So I want to make a function. And then we apply that to v, like that. Let's see if it knows what sigmoid is. No, it doesn't. Yeah. Probably debug tensor. Oh, here it is. Is this inside a namespace then? It's not inside a namespace. I should include debug tensor, and now we should have it. I have it included. Tell me why it doesn't know what sigmoid is. Seems the float types are wrong. my sigmoid float. It's float type, which is what? Float. Duh. I'm just going to make or use a lambda, I think, instead of this sigmoid. Lambda. And the lambda is passed. Of course it's passed something. And then we return that. And do I have a float type? Actually my float types are written float type. So we have something that takes a float type. Let you. And then we return float type 1, float type 1. V, yeah, no, you. Doesn't capture anything. Great, that worked. So now we can print Z, we're still printing Z, and now it's the output of the activation function. So we run it now, then all those values are between 0 and 1. Hello. There it is. And outputs are all between 0 and 1. Great. Next we want to make a residual, so subtract the target from it. So that's a kind of a new function, I guess, because I want to do something. No, come on, I can just subtract tensors. Of course I can. So let's call this the residual R, and then that is equal to Z minus T. Well, we don't have T yet. To make a T out of these targets here. Okay, I'll do that afterwards. My target should be therefore the same shape as Z, which is just a row vector. I really should make a new type, I think, a row vector. Okay, debug code so far. Just do it with tensor T, and this thing has this shape of 1 comma the size is the same size, but well, I use targets. So this one makes it a vector again instead of a matrix, and but one row and this many columns, aka a row vector. And then we have to fill that in as well. Set J to 0 again. Run over all colors. Because these targets are colors. And then fill in T 0, J equals color something. It's green, I guess. That's just true or false, or it's 0, 1. My T exists of what did I say that it existed of? It's going to be float types, but okay. Well, 0 and 1 is storable. Don't forget to increment that. And I think we can just subtract these two. And now we get R, and again I can print R. Let's try to compile that. Compiles. And yeah, now we have values between -1 and +1. I only see -1. Oh, it's almost +1. Very great. Looks like it worked. What is the next thing we want to do? So that's the residual. So this is my initial delta, because that's in the end that's just equal to the residuals. Now again, the gradient matrix is just immediately then to be calculated, or the delta times transpose of x. Seriously, I have to transpose it. And then we're done, I think, because we have only one layer. I'm going to try this. I feel so skeptical. Like 2 weeks work, I don't know. A lot of work. I cannot believe that is going to work. I mean, most of the work went into this README. So all this mathematics. I did a lot of mathematics without being able to test anything. Because, yeah. And now we're going to test it for the first time. And I cannot believe that it's going to work. I'm going to call this one directly. Instead of residual, I'm going to call it delta 0s. Maybe leave the s off. Doesn't matter, I guess. Okay, my gradients should be the same shape as W. So we got now calculate the gradient matrix. It's actually a row vector. And that is delta times delta times the transpose of x. Oh, I don't have to transpose it actually. I can just use contract. Need to keep track of the shapes though. This was what? I think I don't have any matrices at all. So if it is a tensor 2, then it's just a row vector. Oh, I do have a matrix, sorry. X is a matrix. But Z is a row vector, T is a row vector, delta is a row vector. Meaning that we have to run over the columns, I think. Yeah, should be. And then of course, I mean the columns are just enumerate all the samples of the training set. And then I must combine that with whatever dimension or whatever rank of X contains the should be 1, contains samples. So you can see that here it's the second one, so 1. And then that should leave us with I don't know how many ranks, hopefully 2, of which one is 1 and the other one is 3, which then should be the same shape as W, but because I didn't transpose, so I'm not sure. Let's see what gets out of there, if it even compiles. It compiles and we get yeah, we get a row vector indeed, yeah, with gradient. I guess there are large values, 20. Wait, we can only have a radius. Wait, what? What? That's nonsense. Oh shit. Oh shit. I should have been 0. Because I'm starting with the solution. Here, this line here, that's exactly what line that I'm starting with now. I'm using W being this line already. So the gradient should be 0, but totally is not. Pokemon high. Okay, maybe it's just because we have so little points, so I'm gonna go back to 5,000. Yeah, it's still big. Yeah, well, I guess it couldn't work at once. Let's do one more step anyway. Apply the gradient to W. Wouldn't it be nice if you could just type this? Cannot multiply directly. No, why not? I don't know. Maybe it's one line less, but let's do it this way. It's all possible. Tensor reference operator times becomes sine alpha return this, and then let's run over the whole flat thingy. Const, only not const. Let begin on equal end, self plus is block size. Just increment will do. Nobody knows why I'm using self here. Is this the first loop like that? Wow. Okay, what the hell is flat anyway? It's just a vector, I think. Blub, blub, blub. Church. There, flat. It's not a vector. Okay, undo, redo. Multiply every element. Oh, maybe I should call it element. Uncompiled. Yep. So we got a huge positive gradient here, and therefore we decremented that thing. Is that the right direction then? Should one subtract the gradient, or, well, if you believe my readme, probably says so. What to do with it? Yeah. Oh, divided by bit size. Oh, interesting. So let's divide. Let's make this 3 anyway. Or 3, and then divide it by the bit size. Oh wait, that is not possible. I meant like that. That's my size points. Dot size. No, there's a tiny enough adjustment, I think. So let's do that in a loop, and then see if we explode or that it goes to 0 for some mysterious reason. Not plotting it yet, just do this in a loop. W was changed, so V changes. That we can put here outside of the loop. V was changed, so Z changes, Z changed, so delta changed, so D changed. I don't want to print G. Well, maybe I do, actually. Let's print that it is G. G is that. Good. Except that closing brace. Infinitely slowly, the gradient is decreasing. This is pretty rapidly increasing. And here we go from minus 14,000 also down. Nothing happens. Are we going fast enough? Let's just do a million epochs. A million, 10,000. It's scary, but it seems to be working. At least it's going to 0. Yeah, this is just nothing. It's just the same thing. See, the gradient is pretty much went pretty much down. This one was still going down. So let's increase the learning rate a little bit. Hopefully it doesn't get too instable. That one goes down. That one goes down. I'm gonna wait. Still not always gone. Now they're really low. 2, 2, 3, 2. Less than 1, less than 1, less than 1. Wow, yeah. It's stabilizing to something. But what? What is it stabilizing to? It's stabilizing towards W0. Yeah. It looks like it. There's nothing left of my W either, or what? No, that's not true. That's not true. Trying to understand this thing here. What is that? Still the line that I have here? Almost 45 degrees. I think it is. Those two divided with the minus in front of it. Because this divided minus this divided by that one. That is the slope. So it'll be a little bit less than 45 degrees. And that it is. A little bit less. And this shift, this is then... Well, this is distance, I guess. 1-ish. I don't know. Looks like it. This distance looks like a square root of half. But well, maybe just shift it a little bit further. I have to draw. I have to draw the line. I have to draw 3 lines. Now I think about it. Including a circle. Yeah. Oh, it puts it upside down. Oh, interesting. Interesting. So this could be a bug still that it is confused between red and green. That means that I start with the weights that I thought were perfect weights, and my single neuron says, "Oh my God, that's as far off as can be. I have to rotate the line 180 degrees," and that's what it does. Very interesting. That immediately proves that it is super stable and finding it. At least if we actually go to... I'm gonna increase the number of epochs. If I make this 1,000,000, it's 10,000. I make it 1,000,000, it should be good. Well, like totally stable, right? So we suspect that this goes to minus 2.28, minus 1.78, and plus 3.46. And then it works. Except that I got red and green confused, apparently. It's pretty slow. How long did it take before? Already a few seconds, no? So this is going to take several minutes. Means I can eat another sandwich. Yay. I feel like stopping it and then adding a counter so you can see how long it takes before it finishes. Guess we can look at the code at the same time and try to understand why. Mathematica is running. I mean, I don't think it is this minus sign. No, if you would go the wrong way, you go uphill, then it's not going to be stable, and this is stable. It's more that confuses red and green. Maybe you should do T minus Z then. Let's compare with the readme. This is just about a loss function. Although this contains the Z minus T thing. I think there's an easy way to understand this. We just change the sigmoid into a step function, and then we want G to be 0. Let's see. Because the only way for G to be 0 is when delta is 0. This is kind of a constant, just my input. Well, average over all the samples anyway. Yeah, if I make this minus itself, if I negate this, so T minus Z, then it's still 0 when Z and T are equal. Although the gradient is upside down indeed. So changing these two is actually the same as starting to add the gradient instead of subtracting it. ChatGTP also gets a minus sign always wrong. It's a very difficult thing. A standard, so yeah, my x's are, I mean, if you put it like this, so my loss function is the residual, z minus the target, so this is 1 everywhere. And then the delta is z times 1 minus z. Nope, cannot follow it. I want visual feedback, seriously. Come on. Still calculating. This takes too long. So yeah, I want to draw the lines and the circle as a function of this W. And so I just need to split that off from the rest. Let's do that. This is a line draw. Get the scale factor, draw. Determine the intersections with the rectangle around it. This should never happen anymore. Really be surprised. It's just not possible. So I kind of already have it split off. And I can just call this on another line. If W was a line, I can make another line. Hell, I can even have a reference to it. Maybe. Update W here. Should I update a line directly then? Let's try to get a reference. Yeah. I think that should work-ish, except for getting the reference. I mean a non-cons reference. Don't have an H1 here. Oh, in the wrong window. That's why I could not find it. The wrong tab anyway. Crash. Transaction size equals 2 field. Shocking. No, think about it. It did not turn the line around. It just changed the sign. Is that not exactly the same line? Well, it still doesn't like it that this is negative, maybe. Which makes sense, because that can't be negative. Why is it negative? What? Why is it negative? Is my distance negative? No, nonsense. Let's see, distance. Distance can be negative. But okay, that doesn't matter. It's about this one. Oh, the cosine can be negative. Yeah, that should not happen. No, 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 no. This thing stands for S, like in sine as well, I think. Or yeah. I think this is the binary classification. This, you know, here, W1 equals 1 divided by S. Oh, but that's when the line is horizontal. Yeah. So if W0 is 0, then it's a horizontal line. And this would hold. I think we still have the same problem. I think we still have the same problem. It just doesn't want it to be negative. W1 for some reason. But that means that if I generate something that is not negative, then maybe it should not turn it around. And it does too. This is not negative. No, it makes it negative. It makes it negative even. I don't think it's rotating the line, right? The ratio between these two is the slope. And that doesn't change. Let me print it. Damn it, slope keeps changing. Well, yeah, in the light is so much noise. It's kind of constant, I guess. Yeah, the slope is not changing. And the distance, I can print the distance as well. I think that what is turning inside out is the scale factor. So it's kind of, yeah, turns it inside out over the normal. Yeah? Huh? I don't know what happens. Huh? What is this? Why is it suddenly drawing something else? Oh, there's my drawing. Isn't it? Close it. Okay, I think it's time to again for laying awake in bed for 8 hours. I don't even know why I'm still going to bed. I might as well just continue for a few hours. Guess it's because I'm feeling tired as well. I'm feeling tired. Here is not drawing the circles, or the circles are every time exactly at the same spot. How would that be possible? Totally it's not possible, of course. Maybe it is possible. Unlikely, but Well, that would be something if it is so precise, stable. Let's see if it. I'm drawing circles. I might be drawing them, but maybe the reason is that it doesn't do it again because this is not incremented. Let's add a epoch here. Doing this over and over is also a bit silly, of course, these four. So do that before calling this draw. I can do that here in the plot, I guess. Plot. No epoch yet. Oop. Yep, now we have circles. Circles change as well. Right. Cool. What? Even scrolling left and right works. And we're back. Turning it inside out. Ooh, it rotated. Maybe it rotates anyway and I just didn't see it because it happened outside the screen. This one's also going to rotate. Yep. Perfect. Wow, so beautiful. Well, I think I can turn up the loading rate, definitely. Oops. So 10 times as fast. Oh, still, is it even faster? Still goes incredibly slower and slower and slower in the end. Or is it just me? line rule. dead. Defunct knuplot. Bad knuplot. I cannot even kill and kill -9 the defunct. It just remains there. Yeah. What was I going to do? Well, I know. I was going to increment the learning rate by a factor of 10 again. Yeah, that looks unstable. Very unstable. Slope changes. The slope is not stable. Try that again. This one is stable. Pretty fast. 100%. Rock stable. Rock stable. That one is super slow compared to. Dude, what's slow? Stable. That's fast. Quite a shock there. Normally it is at least parallel to the original. That one was tilted. Also tilted. It's really weird. Seed 8867. Don't know, reproduce it. Same thing. So now is set the learning rate again down to 0.1. Yeah, that's stable. Now it finds the red lines. Approaching the red lines. Great. I think I'm going to bed, and then tomorrow I'll fix the, I don't know, sign swap. Still think it's confused being between red and green or something. Not sure what it is. But I start with the perfect weights, so it shouldn't do anything, and then it changes it to the negative of those things. Kind of, right? Neighborhood issues. What the hell? Except in this case. No, it doesn't. What? 0.05 stays that way. No way. Grow. Mine is 0.27. Oh no, I'm printing it. Sorry, I'm printing it after 100 epochs. This is the real value that it started with, so it did negate it. This one as well. So this one is minus 2.8, and it goes to, well, 2.8. This one was minus 0.08. And that's where it goes to. Yeah, so 1% off. But that could be just a noise, I guess. The randomness in it. Let me try one more time with a huge amount of points. We'll do 50,000 points. It's probably going to be 100 times slower, but or not. No, not that bad. Now it's 0.07. Wait for it. Yeah. So is this more exactly what it was? Oh, it's going past it. Wait. So it should be 777 or 778. Going past it. So disappointing. This is 2.811. Yeah, also not even close. Yeah, no, I don't know. I don't know. I would say a lot of points should make it more accurate. Just rotate it a little bit. Oh, I think I understand why. It's because it gets cut off at the edge here. So the distribution is perfect here, but the graph just suddenly stops here. So that's why we get a deviation. If I make the field much larger, like say 5 or 6 even standard deviations, well, then I think it should be very stable. I mean very precise. Let me do that. Let's go to generate points. Colors. Point. Generate points. It gets the X and Y range from my line. That is here, and that's there, and that's 6 now. 6 standard deviations. It is very unstable, probably only because of floating point roundoff errors, I think. This area is so bloody green. It's but then eventually it should go better. No, it's not going fast. This has to go to 0.077. It's gonna take forever. So maybe less points is better. Then we don't have such less points. I don't know. This is a bit much points. 5,000 points. Super unstable. Kind of the same thing, even though we just have the 10% density of the points. That's interesting. I wonder how much it is influenced by the fact that, well, it is still cut off, you know. I mean, even if this is 5 standard deviations or 6 standard deviations. Why the hell do we have a green point here? I mean, if this is 6 standard deviations, that's like a few points at 5 standard deviations. How? No way. Anyway, even if this would be nice distribution, then there is a cutoff here that is diagonal to the line. So that means that it sees more green here than that red. Red was cut off and green is added, as it were. So that would mean you would think that it is being pushed this way. Rotates clockwise a little bit, but actually it has rotated counterclockwise because the red line here is the correct line. It's more like it got sucked into the green. Not sure if that makes sense. Let's try horizontal lines. Still a tiny little bit rotated. The red line is here and it goes there. But yeah. So this slope should be 0, right? And it's not. It's 1% off. Hopefully you get an equal amount of negative slopes in. That would explain. Whoa, what happened? What is happening here? Stabilize already. Wow, it's really unstable. It's pretty weird. Bang. You know what? I think that the gradient ratios are not equal, and I should divide. I should divide them. It looks like the slope is over. What is it? Feedback is too big for the slope, but not for the bias. So what happens if, say, instead of just using this, I'm just crunching down on G itself, Can I change that? T, 0. Let's try that one. Much better, isn't it? Stable like hell and pretty fast. Yeah, I go to bed. So much more to do. Could take forever. Good night.